Alright folks, in this video we're going to be talking about systems of linear equations, and specifically we're going to be talking about the number of solutions that are in the system. So yesterday, in the last class, what we talked about was this situation, where you and I saw two lines, two equations that intersected. How many solutions are here? We know from 8th grade we learned and we were reminded in last class that the solution to a system of equations is the intersection point of the two equations, of the two functions. So here we have the two equations, 2x minus 2, which is this one, which has a y-intercept negative 2, 1/3 x plus 3, y-intercept of 3, a slope of 1/3. Now what is happening to these two lines? These two lines are intersecting. And when they intersect, look at the slopes. These slopes are different. So our m, they are different. Let's look at the y-intercepts. Positive 3, negative 2, those are different. When we have intersecting lines where the slope and the y-intercept are different, so we can look at the equations and we can see that these are going to intersect at some point somewhere because the slopes are different and the y-intercepts are different. We know that there is exactly one solution. There's one intersection point. This one happens to be at 3, 4. Well, there's another scenario that we need to look at. Not all lines intersect. Sometimes lines look like this. Now let's take a look at these equations and let's see if we remember from last semester what kind of lines these are. Let's look. The slopes are the same. Well, what kind of lines have slopes that are the same? Parallel lines have slopes that are the same. So our m is the same, and our y-intercepts are different. Now let's think about this for a second. How many solutions are there in this system? If the lines never touch, can there be an intersection point? No. Well, the intersection point, the solution, is where the two lines cross. Well, if the lines never cross, then there are no solutions. There are none. And this last scenario that we need to look at is this one. Now, we have two equations here. There are two equations, but there's something very interesting happening right here with these lines. I only see one line. But let's take a look at these equations again. There's some division here that can happen. Let's simplify this and see what happens. 15 divided by 7.5, you put that in your calculator, and that equals 2x. 12 divided by 4 is 3. Oh, so these are actually the same equation. Sometimes you'll run into situations where you'll end up with two different situations. Well, they have different numbers, but when you simplify them out, they'll be the exact same equation. So when these lines overlap, or when they're on top of each other, what's the same? Well, the slope is the same. The y-intercept is the same. Now let's think about this for a moment. How many times do the two lines intersect? Well, they intersect here, 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 and here, and here, and here, and here, and here, and here. So how many solutions are there? There is an infinite number of solutions. So ladies and gentlemen, what we're going to do in today's classes is we're going to solve systems of equations, but with three different kinds. We're going to solve systems that intersect, solve systems that are parallel, and solve systems where the lines overlap, where they're right on top of each other. And a couple of ways we need to learn how to do this. We need to be able to look at the graph. We need to be able to see that the lines are parallel or that the lines overlap. And then it's also tremendously helpful for us to be able to look at the equations to see that these are different slopes, different y-intercepts. I have one solution. I have the same slopes, different y-intercepts. That means the lines are parallel, and therefore I'm going to have no solutions. And finally, when the lines are exactly the same slope, same y-intercept, I have two lines that are exactly the same. That means that there are an infinite number of solutions. In the next video, I'm going to work through an example problem for you guys.